The Panama Canal is one of the greatest and most ambitious engineering projects in the history of the Americas. This marvel of engineering connects the Atlantic Ocean with the Pacific through an ingenious system of locks that lift ships 26 meters above sea level. When a ship passes through the lock system, the canal loses a total of 200 million liters of water, running the risk of drying out. But how do they manage to lift a ship weighing over 53,000 tons? In this video, we'll discover how the Panama Canal works when ships pass through it. For hundreds of years, sailing around South America cost time, money, and lives. But in 1914, one of the most expensive and ambitious engineering projects in the history of the Americas was inaugurated, the Panama Canal. Since its opening, over 1 million ships have used this route. Connecting the Atlantic and Pacific Oceans by waterway was humanity's dream for more than 500 years. Joining these two bodies of water would provide an extraordinary advantage, saving ships a travel distance of 20,000 kilometers and 2 weeks of journey time. Thanks to the canal, ships can navigate from the Atlantic to the Pacific in just 8 hours, 40 times faster than the voyage around Cape Horn. Every year, approximately 14,000 ships traverse the 80 kilometers of the Panama Canal, transporting 172 million tons of goods. This transcontinental corridor generates significant revenue for the Panamanian government, contributing $2 billion annually in tolls. The largest ships can pay over $500,000 to cross the canal. It all begins when a container ship approaches Limon Bay. The Caribbean entrance to the Panama Canal departed Israel 3.5 weeks ago, transporting containers to China. It sails through the Atlantic Ocean en route to the Pacific. The main obstacle in its path is the Americas. While traveling from New York to Los Angeles via the canal takes 10 days, it requires 24 days when circumventing South America, meaning a difference of 14 days. Although the Panama Canal is over 100 years old, it remains essential to global trade. This man-made trade route faces significant challenges to reach Panama City on the Pacific coast. The ship must navigate a series of complex and narrow channels and locks. The canal's narrowness contrasts with the size of the ship, which is larger than the Titanic, weighing over 53,000 tons. It belongs to a special generation of ships known as Panamax vessels, the largest capable of passing through the canal. But it is very dangerous to sail in the dark, so the ship only has 8 hours to cross it before nightfall. To complete the crossing in time, the expertise of a specialist is required. The Panama Canal is the only place in the world where a captain must relinquish control of their vessel. At this point, the canal pilot, who has been guiding ships through the canal for 16 years, takes over. However, even for him, steering such a large ship is a challenge due to its enormous size. Today, a second pilot will assist the captain through the canal. Navigating the canal is a highly specialized job under intense pressure from start to finish. The smallest error could be catastrophic. It takes 8 years of intense training to become a canal pilot. On a typical day, about 36 ships cross the canal in both directions, transporting 450,000 tons of cargo from the Atlantic side. The ship will have to cross 3 locks that will lift it 26 meters and lead it to Gatun Lake. Another set of locks will lower the ship until it reaches sea level on the Pacific side. Building the Panama Canal was the most impressive project of its time and remains one of the greatest engineering feats ever accomplished. It all started in 1880 when the French attempted to construct a canal at the site, but they failed spectacularly, and 20,000 workers lost their lives in the process. Landslides, torrential rains, and diseases were the main issues. The United States took over the project where the French had left off. However, the Americans came up with a brilliant idea. Instead of completely digging through the land, they decided to remove part of these enormous mountains and flood the entire stretch with water. It was a superhuman effort plagued by problems, including diseases and landslides, that claimed the lives of another 5,000 men. An hour after entering the canal, the ship has traveled 11 kilometers from the Caribbean entrance. It is approaching its main challenge, the Gatun Dam, 1 kilometer into the canal. The ship encounters the first set of locks, the Gatun locks. Each lock has 3 independent but interconnected chambers. The Gatun Dam consists of 3 interconnected locks that link the Atlantic side of the canal to Gatun Lake, which is 26 meters above sea level. The problem is that Panamax ships, over 300 meters long, are as large as the locks. The ship measures 300 meters in length, and the lock is 320 meters long, leaving little room for error. The challenge is not just maneuvering the ship, but also its heavy 66,000-ton cargo. If damaged, the ship won't be able to navigate, and if the lock is damaged, the Panama Canal will close. To make matters worse, pilots must steer the ship from the bridge over 220 meters from its bow, with limited visibility. It takes 30 minutes to merge chamber. Specialized operators throw mooring lines to secure 2.5 centimeters thick steel cables to the bow and stern of the ship. These cables are connected to 2 powerful locomotives known as mules, which run along both sides of the canal. Each of these 50-ton mules tows ships up to 100 times their weight, gradually guiding the ship into position. Each locomotive can tow 32 tons and costs $2 million. The captain is nervous. His ship is 32 meters wide, while the lock chamber is only 33.5 meters wide, leaving less than a meter on either side. The maneuver requires surgical precision. A strike inside the chamber could breach the hull, forcing the canal to close. By constantly adjusting cable tension, the locomotives keep the ship centered in the chamber. The lockkeeper closes the Caribbean gates. These massive gates, over 2 meters thick, are designed to withstand water pressure even when closed. Once sealed, operators open valves to fill the chamber with fresh water from Gatun Lake, raising the ship. Gravity allows water from the lake to flow into the lock chamber through 100 openings in the floor. Water begins to raise the ship to the level of the next chamber. The water must flow steadily, otherwise, turbulence could crush the ship against the walls or snap the half-ton steel cables with such force that they could cut a person in two. It takes just 8 minutes to pour 80 million liters of water into the lock, lifting the ship 8 meters. Once the ship is raised, the locomotives move to the next chamber. Then, the 680-ton gates open. However, the ship must still rise 18 more meters, so it enters the middle chamber, where the process is repeated. The process continues until the ship reaches the lake level, 26 meters above the Atlantic. The moorings that keep it attached to the mules are released, and it proceeds toward Gatun Lake. The first phase of the journey through the Panama Canal is complete, but it's 1 p.m., and there are only 5 hours of daylight left to navigate the canal's dangerous stretches. There's no time to waste crossing Gatun Lake. This 431 square kilometer freshwater lake, once the largest artificial body of water, is the canal's great engine. It pumps nearly 200 million liters of water into the locks to raise and lower each ship that passes through. With a daily transit of up to 40 ships, about 7.5 billion liters of water are pumped daily. The lake was created by constructing the immense 27 million-ton Gatun Dam on the Chagres River. The Chagres River is vital to the canal's water supply because every time a ship passes through the lock system, the canal loses a total of 200 million liters of water. If left unaddressed, Gatun Lake would eventually dry out, and the Panama Canal would cease operations. Fortunately, lost water is replenished by the river, ensuring the canal doesn't gradually dry out. When the dam was built, a large hydroelectric plant was also constructed, generating enough power to operate the canal system. 5 hours into the canal, the ship reaches the final stretch of Gatun Lake. Only 30 kilometers remain to reach the Pacific, but now it faces another challenge. The ship has arrived at the narrowest part of the canal, known as the Culebra Cut. The Culebra Cut represents the greatest engineering feat of all. The scale of the work was staggering. A massive amount of dynamite was used to blast millions of tons of rock, creating a channel through a mountain range. A gigantic explosion created an 18-meter breach in the Gamboa Dike. 6,000 men worked to transport the rocks under the constant threat of landslides, constructing the 13-kilometer-long Culebra Cut. Water from Gatun Lake immediately rushed into the Culebra Cut, connecting the Atlantic and Pacific Oceans for the first time. After 3 tense hours, The ship leaves the Culebra cut, but its pilot still cannot relax. It's already 4 p.m., with only 2 hours of daylight remaining. The next step is to guide the ship through the Pedro Miguel and Miraflores locks. These two locks will lower it to sea level, allowing it to continue on its route through the last 5 kilometers of the canal. They operate using the same process as the Gatun locks, but in reverse. As the ship enters the lock system, the combination of gravity and gates lowers the ship 26 meters, returning it to sea level, where it can finally head toward the Pacific Ocean. The ship's transit from the Atlantic to the Pacific took only 8 hours, saving 14 days compared to the journey a century ago. Like this video if you enjoyed it, and share it with someone who might find it interesting. Also, subscribe to this channel and activate notifications to keep learning.